Hi, Andrew. Can everyone hear me? We'll do a check on the audio. Good. Okay, give me a few moments to get the next bit. We still have about 9 minutes before we officially start. Look at this now. Let's see. Right, I am sharing a screen right now, which is essentially the homework. Can you see that? So this would be question 1 and 2, for instance. Does that look similar to your questions? The numbers, of course, probably will be different. Hi, Anya. Can you hear me?
Yep.
Okay, do a head count. Kai, I can see your thing, but can you hear me as well?
Yeah, I can hear you.
Good. Andrew, you put your thumbs up, I guess, so you can still hear me, right? Yeah. Chance, you're good?
Yeah, I'm good.
Right. Okay, we still got, maybe 8 minutes to go. Well, let's use this time to officially get started. Any questions about, what's the test and when is it happening, or just anything? Any questions?
It's on Sunday, right? Or
Yeah.
Sunday?
It's on Sunday. It's not like a usual test like Sunday at 2:30 p.m. in the afternoon that's a fixed time. What happens is that essentially 1 minute after midnight on Saturday, right, into the first minute of Sunday, right, until almost midnight of Sunday. So you've virtually got 24 hours. In that window, when you start, whenever you start, so you might start at 12, you might start at 5 p.m. Once you enter the test, then the clock starts ticking, and you have got 150 minutes to get as many questions, hopefully them all fixed and good. And you will do the test just the usual way. There's boxes to put in your numbers and so on. You're definitely going to have to do some working for quite a few of them. And so write down the working on your pieces of paper that you've got. And then when the test is finished, you've got what's left of that day to get the working copied using, I've got Cam Scanner. I've give you a link on Canvas how you get that. But you might have other ways of doing it, and that's fine. But get them together as a single PDF, and then you go into Canvas, and there's a link there that you just basically click on, and there's a video that shows you what to do, and you will upload that PDF file of your working, and that will be your test over. And I will use the computer grading, and then I will adapt it according to the partial credit that you get for any question that was mostly right, but maybe you made a little mistake somewhere on the way. And so instead of getting 0 out of 5, you might get 2, 3, 4 out of 5. So that's kind of how it's going to go. Have you looked at Canvas to see how easy it is to upload your PDF? Are you comfortable about how you're going to be able to do that? That's a general question to anyone that's here. Yeah, okay. Anything else? Some people, thankfully not many of you, were having issues with re-upping your WebAssign. You know how it's like, if you haven't bought it, it's 2 weeks free, and then you just re-up the 2 weeks and you get another 2 weeks until the quarter's over. Have you found that okay?
I was having trouble opening mine.
Right. I haven't got it handy, but I did check with the rep, and it is correct. They gave me some instructions. If you hold on a second, I think I have them on a piece of paper. I can kind of give you the gist of it. I've got quite a few pieces of paper here, so who knows. Yeah, here it is. You probably won't be able to read this, but because it's a scribble, so I'll just read it to you. You do the www.login.cengage.com. So that may not be your normal way of getting in, but this is what you do to re-up your 2 weeks. So www.login.cengage.com. Now, once you've logged in, you just sign in with your usual username and password, and then you should be in the right place. I think it's called, it's not called the desktop, it's got some other name that escapes me right now. But on the top left-hand side of the screen, there's a big yellow button that says Start Trial, and evidently you hit that, and you get your next 2 weeks, and that's your good. So, I know it's a bit cryptic, but that's what I could write down in the time she was telling me and what I recollect. But I mean, if you have issues, don't pay. But tell me really quickly. Don't tell me on Saturday night, oh, I couldn't get in. Can I get a week extension now? Because that's your responsibility to tell me, promptly.
All right.
If you have an issue, I can contact them. They will go in and they will fix it so that you've got your access again, right? So I don't want you getting panic and just saying to heck with it, I'll spend $100 and that's me. I don't need to worry about it. $100 is a lot of money, and you're a student. So if you're anything like me, you're always broke. So you probably don't want to do that. So if you have an issue, yeah, I did what you said, or I couldn't get through to what you said, I'll get in contact with them and get them fixed for you. It's a good idea when you're doing it anyway to do things early just to make sure. I know that you might have other classes and you think, I'm not going to start my math till Wednesday, and then find out there's problems, because you really that Sunday's going to come up like a jet on you. It'll be surprising how quickly the time's going to fly by. You all know that the test is on all chapter 6, right? So what we've done from week 1 and week 2, and that's pretty much how the tests are going to work. 2 weeks of test, 2 weeks of test, and so on. Well, I've still got about 3 or 4 minutes. I have some more people coming in. Let's see what we got now. Okay, that's Munko, he's in. We'll start in, say, about 3 minutes from now. Any other questions? It was a good one about the, getting your 2 weeks again, because, okay, here we go. Looks good. Hi, Ashley. Don't know, can you hear me now? You can't hear me, can you, Ashley? Or can you? You can, okay. Hi, Daria. Oh, she's still connecting. Hi, Tiara. That's you in? Okay, looks like we've got a couple more coming in, and that should be us. Well, welcome everybody. I'm going to do a lesson today on the first of the three sections that we have to do in chapter 6. So this is 6.4, and it's the inverse trig functions. Now I'm going to see if I can do this. Okay, that looks good. Most of what I want you to get from this section isn't so much the theory part, but I want to do a little bit of theory just to get it out of the way. Most of the questions are involving you using inverse functions to find missing angles in right-angled triangles. That's kind of what their job is. So before we get into the theory, let's just show you the kind of situation that you might get. You'll have a right-angled triangle, and typically you'll know two sides. That's pretty much the going rate. And then there will be an angle somewhere. And the problem simply becomes, how do we find the size of this missing angle? And we're going to use the inverse sine functions to do this. Right, so let's pretend this was our first question. Well, what you do is that you use the angle, the one that you're trying to find, as the angle that you're going to observe the sides from. So this fellow over here is the opposite. And this fellow here is the hypotenuse. And then we're going to use a guy that we've already used, so hopefully we're all quite familiar with it. We're going to use this guy called SOHCAHTOA. Now, one of these three uses the opposite in the hypotenuse. And that's how I know which one to use. And so I'm saying, okay, opposite hypotenuse, oh, there you are. And so I can then write the sine of theta is the opposite over the hypotenuse. And that becomes the sine of theta is 5/12. Now we could spend an awful lot of time guessing. I mean, you could turn 5/12 into a decimal and you could say, I wonder if 42 degrees is close. And then you could keep doing it until, I guess, if you got really lucky, you could do it. But that's probably not a good way to approach it. Of course it's not. So in 141, do you remember there's this thing called the inverse function? It basically undid something. So the inverse of x squared would be the square root, right? And we used a funny little -1 symbol that looked like a power, but it's not, it's just a symbol. Well, we're going to do the same thing here. If you want to find the angle theta, you simply just take the inverse sine of both sides. Now, the inverse sine of a sine cancels out, so that's how you're going to get theta. And then at this point here, you got your calculator, which I've got, so this wouldn't crash on it. Well, I've never done that before. Okay, well, I'll get this and hopefully make it go away in a second. All I'm doing right now, if you can't see it, is I'm finding out what the inverse sine of 5/12 says. Where the heck am I? $24.6. Hopefully when I close this, I can get you all back again. There we go. So I kind of disappeared there. I don't know quite what you managed to see, but that's the bit that's on your calculator. Now, if you've got a TI 3 or 84, and your calculator looks something like this, you'll see a button up here, top left, and then you've got your sine, your cosine, and your tangent button. So if you do second sine, you get the inverse sine, second cosine, second tan. So there's the three guys that we're getting. Now that's essentially the gist of most of these questions that you're going to get later. You're going to get some triangle where you'll know two sides, and you're being asked to find the third. The third piece of thing is, in this case, one of the missing angles, right? Now, occasionally they also ask you for the third side. And a lot of people go and they do some really hard work and they go a kind of scenic route. Do you know Pythagoras will do the job? So, you know, you don't need to use trig if it's not necessary. For instance, won't 13 squared equal 5 squared plus this missing one? And I happen to know the answer to this because it's a pretty standard triangle, it'll be 12. So if you get the question, and what's the side? Now, I know towards the end they do something to do with a ladder, for instance. I don't know if you've seen that question, where they put a ladder against the wall. And one of the questions was the angle of elevation, which is just a fancy way of saying find this angle where my finger is, the theta. And then the second question is, I can't remember if it's how high up the wall or how far away from the wall it is, but they're equivalent to that. So that's the gist of what we're going to do. So I'm going to return now to a little bit of the theory, but I'll try and keep it basic. There are three inverse trig functions: inverse sine, inverse cosine, and inverse tangent. There's buttons on your calculator that will do that. If I tell you that the inverse sine of theta is a half, and you're thinking, what am I trying to figure out here? What am I getting? I should say, excuse me, I'll start again. If I'm being asked to find the inverse sine of a half, that's what I should have said, right? What you're trying to find is an angle whose sine is a half. So the inverse sine of theta, right, this guy here, theta could be anything, it could be a half, 2/3, is the angle, right, that has a sine that's equal to that. So if you're trying to find the inverse sine of 5/12, you're trying to find some angle that has the property that the sine of this angle is 5/12. And we're actually going to use this relationship. If I tell you the inverse sine of 3/5 is theta, that's the same thing mathematically as saying that the sine of theta is 3/5. Although they may not look very similar, mathematically they've got the same information in it. A analogy. Do you know if I said to you the square root of 36 equals 6? Do you know that's the same information as 6 squared equals 36? So if I tell you that theta is inverse sine of 3/5, it's the same thing as me telling you that the sine of theta is 3/5. And that's kind of all you need to know from the theory. There's a little bit about the theory that says when you do the inverse sine, you only get answers between -pi/2 and pi/2. We talk radians here. If it's an inverse cosine, you can only use it. The answer you get can only be between -pi and pi. 0 and pi. And when you do inverse tan, it's from -pi/2 and pi. But for most practical purposes, that really doesn't do much. I mean, it's not going to be a big thing. So let me stop sharing for a moment and I'll return to our first homework question. Can you all see that homework question, 16, 34, and 30? Right. Now you'll get a homework question like that. In this question here, they're just getting you used to the inverse trig functions. So if I scroll down, I'll kind of show you what's going on here. This angle theta, right, this mystery angle theta, is the inverse sine of, where are we? Well, from this angle's perspective, damn it, what can I show you this? Can you see my mouse pointing? I'm never quite sure what you get to see here. Can you see this mouse pointing? Okay.
Yeah.
From this guy's perspective, won't 30, this guy here, be the opposite? Won't 16 be the adjacent, and won't the hypotenuse be 34? Are you happy about 30 is the opposite, 16 is the adjacent, and 34 is the hypotenuse? Now, if you ever see a right angle triangle and its orientation is kind of weird, or for some reason that little right angle symbol is missing, do you know that the longest of the three is guaranteed to be the hypotenuse? And right, you're halfway there once you know that one. Right. Now, if I said to you, let's look at angle theta, and I said, okay, what's the sine of theta? Well, the sine of theta in this case would be opposite over hypotenuse, 30 over 34. Well, isn't 30 over 34 15/17? Do you see where that's coming from? And if I said, okay, what's the cosine of theta? 16 over 34, which is 8/17. And if we went the third one, we did the tangent, 30 over 16, and which is that one. I'm going to skim by a couple of these guys. Most of them, I have solutions to all of these, so although I don't have time to do every single question, when sometime later tonight, if you go and you look at Canvas, I've basically done all the important questions from this section. So anything I don't get around to doing, you'll see my example, and you can read it over. And for instance, see these bunch of questions here? Do you know that's just a matter of hitting the right button on your calculator? And make sure that you're in radians or you're in degrees, whatever they ask for. In my particular questions here, I think everything is in radians, so make sure your calculator is in radians for those questions. Okay, so let's look at our first question where we actually get to do stuff. Well, that's a classic one that you're looking at. This is question number 10. It looks something like this. Okay, are we good? Let me, what I'm trying to do is get this fella to be the main screen. So, oh, I forgot. That's why. You got to remember how to do this. I'm not great at it yet. Okay. Can you see the right angle triangle that I'm talking about now, the 610 fella in theta? Are you seeing that? Now, in your case, it might be the small one, so there is another way for me to do that. I think what I might do instead, yeah, I think I know what I can do. I'm just trying to make it a little bit bigger so we can see it. Can you see it now as a big version? If you click on it. Well, let's just assume that we can. Even if you can't, at least I know you can see it as a small version. So here goes. From this picture, step one, use this angle theta to name this side opposite and to name the one next to it, this one here, hypotenuse. So I'm looking at this and I'm thinking, okay, how's this going to work out? Well, we have SOHCAHTOA. One of them uses opposite and hypotenuse, which I know. It's a sine that does that. So I try and approach these questions systematically, pretty much the same way each time. And so my next line would be, okay, then that makes the sine of theta 6 over 10, which you might want to call 3/5. And then the killer line, this is the line that gets you to the end. If you want to get theta, can't we just find the inverse sine of 3/5? Now, the inverse sine of 3/5 3 divided by 5 is this fella, really using a very primitive calculator. 36.9 degrees. Okay, is there anything about that step that was unclear that you would like me to maybe get into? Are we cool with that one? We're good? Okay. So can you see that it's a triangle, two sides, one angle? Most of the time, they want to know the angle. Now and again, they'll ask for the other side. If they do, just use Pythagoras. Okay. So I'm now going to lots of buttons here. I'm trying to make sure I don't kill anything. Here we go. Right, so far so good, Dan? Okay, so let's share some more questions. Okay, so what you should be looking at now is question 10, question 11. Is that what you can see? Right. Quick, very quick. Do you see two sides, missing angle? Two sides, missing angle. Pretty much the same question, just different numbers. It's getting a bit boring now. Two sides, missing angle. Let's just pause on this one for a minute. Once you've done enough of them, you can pretty quickly get into the swing of things. Inverse sine, inverse cosine, or inverse tangent. Which one do you think is going to be the finishing touch to this question? Will I be using an inverse sine at the end, an inverse cosine at the end, or an inverse tan? Looking at it, what do you think?
Inverse tan.
Ah, perfect. Agreed. Daria, do you agree with that?
Yeah.
Yeah. Just in case you don't, from this angle's perspective, won't this fellow be called the opposite? And won't this one be called the adjacent? And this one here that we don't care about is hypotenuse. An opposite over adjacent is a tangent. So you know you're going to end up with that particular storyline. Now it's a bit same old, same old. Can you see in this question here, it's a 30 and a 90. And yep, it's find the missing angle. Well, let's go for that. Inverse sine, cosine, or tangent this time?
Sine.
Very
Yeah,
quick.
sine.
All agree? Give you a few moments. You're happy?
Fine.
Right. So it's not as scary once you kind of see the process, isn't it? I mean, once you've seen two or three of these, it's really just practice. It's just making sure that you see an inverse sine, an inverse cosine, an inverse tan, maybe a couple of each, just so that you feel comfortable, you know, in naming the sides, picking the right formula, and finishing off with a nice inverse sine, and you call it good. Right. Now, they've got a couple of questions, 15 down to, is it 20? And 15 down to 20 is a different kind of question, and I will do those, guys, but I thought in the time that I've got, I want to make sure that I do the application ones first, because they end up being very similar to the triangles I've just did, and then whatever time we've got left, I'll go back to the ones I've skipped by and show you how they're done. Okay. So in question 22, you've got a ladder against a wall. So here's the ground, here's the wall, there's a ladder. I don't see how you can't do, I don't know, that's a double negative. You need to draw a picture to do these questions. If you don't draw a picture, I can't really see how you can keep track of the information and not, you know, slip up somewhere. So it doesn't need to be a great picture. I'm not the best artist in the world, but verticals always meet horizontals at right angles. And then I can look at the story and I say, okay, it's a 20-foot ladder, so that makes that 20 feet. The base of the ladder is 9 feet from the base of the building. That makes that guy 9. And the fella that they're asking us for in this question is going to be 63 point, oh, that's going to be the answer, is going to be this missing angle in here, theta. So I know this is a little picture, but is that enough, or do you want me to zoom in and zoom out and do all that carrying on? You're cool with it. I know it's a small picture. You know, you can click on it and pin it to your screen and make it a larger picture for your own benefit if you want to. You know how to do that? If you don't, if you put your mouse pointer over it, you'll see 3 little dots. If you click on those 3 little dots, one of the choices is pin video, and it becomes a big version. So you can do that for your own benefit, right? If you want to do it, because you know it's too tiny, that's good enough for me. Right, so I got my picture. I'm ready to rock and roll here.
This is. Can I ask a question?
Sure.
So from the top of the ladder, is that angle called a downgrade?
This angle here?
Yeah.
That angle that's in, let me draw another picture so I don't waste my own diagram so much. This angle in here, if that's the one you're talking about, right?
Yeah.
That one doesn't have a name. There is one that you do get a name for, and it's this angle here. And this angle in here is called an angle of depression.
Oh.
Now, I don't know the name that you use, so I can't guarantee that there's not some textbook somewhere that they give it a name, but I don't know a name for it, so it doesn't have a name. Okay?
Thank you.
Right. Now, we got this fella here. I got a process that has been very successful in the past, so I'm going to stick to it. So my process is, let's find out who these 2 guys are, what their names are. Isn't 9 the adjacent? Right? What's the 20?
Hypotenuse.
Right. Which one of the 3 trig functions uses the adjacent and hypotenuse?
Cosine.
Right. You know, it has a flow to it, doesn't it? Right? Name the sides, pick the right trig guy. Now, the cosine is adjacent over hypotenuse. The cosine of this missing angle is 9 over 20. Sometimes you can simplify it, not here. And now we're left with one final step. It's the inverse cosine of 9/20ths. And that will give me my angle. And I'm assuming, because I've got that question in front of me and it tells me the answer, that in this case it's 63.3 degrees. Are we cool?
Yeah, would that also be, that angle also be considered the angle of depression then too?
If you look at this picture and I add a little dotted line and I looked at this angle in here, there's a piece of math that says that this angle and that angle are the same size.
Yeah.
So in that case, you are correct. I don't have great benefit in doing that because I like to keep them separate, because some questions, you know, like the aircraft looking down is angle and depression, but a guy in the ground looking up to the top of a building is elevation. And sometimes if you're told, for instance, the angle of depression, people use it as if that's the number that is part of the triangle, but technically that number belongs down here and not everyone does that correctly.
Okay.
Now, there is a second part to that question. They ask you for this distance here. Right, that's part 2 of the question. How would I find that?
Pythagorean theorem.
Yeah. Now, I don't need inverse cosines or weird stuff like that, although there are ways you could use trig functions, but I would choose not to. I would simply say, oh, 20 squared is x squared plus 9 squared. That makes 400 x squared plus 81. That makes 319x squared. And then I would find on my calculator the square root of 319, and I've been told at least to the nearest whole number, because that's all they wanted in this question, that the answer is 18. It's probably 18.2 or something, right? But 18 is the nearest whole number. Are we cool with that question? Right, let's move on to the last one of the application questions, and then we'll return to those ones that I skipped. Any more questions before I actually start doing that? Okay. Are we good? Right, so the next story, we have the ground and we have a tree. And it's a 96-foot high tree. And it casts a shadow, so that means this distance here to here, that's the shadow, is 120. What is the angle of elevation? There we go. Can you see now that I've set up that question, isn't it for all intents and purposes very similar to the other one? To speed up things a little bit here, am I going to use inverse sine, cosine, and tangent at the end? I won't, you know, that'll be my last line, but which of those three am I going to use for this storyline?
Tangent.
Tangent.
Agreed? Opposite adjacent. Right, you've got 3 or 4 lines of working, but basically, you know, you've nailed it. Yeah, draw a picture, put in what you're told, figure out, in this case, it's going to be missing angle all the time, essentially, right? You got your angle. I think that went pretty well, didn't it? You feel comfortable, if you didn't already? Okay. Now, our last piece of today is winding back to these questions here. They start at 15. And they finish out, well, I think it's 21, 22, something like that. Now, let's show you what happens here. The sine of theta is equal to 7/9. And we're being asked to find all the angles that theta could be. But theta has to be between 0 and 1a. Oh, is that your baby at the background, Ashley?
No, he's a little boy that we're watching for my husband's coworker.
Oh, that's nice of you.
I do have 3 sons though, much older.
Oh, much older. Okay.
Yes,
I should give them the job of looking after the kid then.
I agree.
Okay, we're cool. I'm just going to try and see if I can pin this one. It's always a mystery for me. Okay. So I'm doing the big version. Hopefully you can make it the big version if you can't see all of this. This is where a little bit of the theory that we did at the start comes in. Do you know that when you use the inverse sine function, the answers that you get always range between negative pi upon 2 and pi upon 2. That's just the way they work. So that if you put in the inverse sine of, say, 7/9, oh, by the way, that's the same thing as negative 90 degrees and positive 90 degrees, which is much easier for humans to understand. Now, if you go to your calculator and you find the inverse sine of 7/9, you will get an answer. You will get the answer 51.1 degrees, just hitting buttons on your calculator, right? And you might think, well, I'm great, that's it. But we already know that if you look at all sine, tan, cos, isn't the sine function positive in the first and in the second quadrant? And if I'm looking for an angle whose sine is 7/9, which is positive, doesn't that mean I'm looking for an angle that's in the first and the second quadrant? So if you imagine what we've just found that guy. There is another fella over here. And this guy you get by doing that calculation. So there will be two answers, this one and then that one. Now you're going to have to kind of trust me a little bit in this, but there is a reason why this angle here is 180, take away the first one. Can you imagine that you're doing a unit circle? Do you know the guy that's 30 degrees doesn't have the same sine as the guy that's 150? And you can look at your unit circle and check that. There is a symmetry between these two, isn't there? If this one on the right was 10 degrees, the one on the left would be 170. Right? 10 away from the x, 10 away from the x. You're basically making this the same size as that. So you know that a straight line is 180 and then you work backwards 51.1 to get the missing angle. So that's kind of the trick to doing the two angle question. You're always going to get one from the calculator, right? But the answer that you get isn't always going to be the only one that's there. So bear that in mind that some answers, that's the case. To give you a slightly different version of this is question 16. If I asked you to solve this problem, you're going to be looking for the inverse cosine of 5/9. And the answer that you get here, that there's only one. And you might say, well, why is there only one if you're still going to pick angles between 0 and 180? Well, if you look at all sine, tan, cos, in the first quadrant, the cosine is also positive. But what about in the, the 90 to 180 range? Do you see that the cosine will be negative there? And so the only angle in the range 0 to 180, which is positive, is the 56.3 degrees one, which is what this is trying to say. So where all sine, tan, cos. So where is the other positive one? The other positive one is here in the fourth quadrant. Now, if I've got an angle and this guy is 56.3, the one that I would be getting would be that one. They didn't ask us anything like that, but if they did ask me to get that angle, wouldn't you just say 360 take away 56.3 and that would be the other one? So those kind of questions get you through 15, 16 and 17. And now the last group of questions. Question 18. It says, find the exact value of, and this is kind of really weird looking. You're finding the cosine of an inverse sine of a fraction. And the first reaction would probably be, what on earth is that? I've done inverse sines before, I've done cosines on their own before, but I've never done a question where you start putting both together, right? And so we have to figure out a method for solving this particular group of questions. So here goes. First thing I'm going to do is I'm going to call this bit here, I'm going to call it theta. I'm going to say theta is the angle whose sine is 15/17. Now, if you take the sine of both sides, that's the same thing as saying the sine of theta is 15/17. But I know that the sine is an opposite over a hypotenuse. Great. And then I can build a right angle triangle where this is the opposite, this is the adjacent, and this is the hypotenuse. And I can put an opposite of 5 because that's the top. The hypotenuse is 17, so that's the bottom. And then all I need to do is find the third missing side. So I got 17 here, I got 5 here. How do you think I'm going to find the third missing side?
Pythagorean theorem.
Right. So what we got? 17 squared is 5 squared plus, call that x, plus x squared. Brain's not, I need to get a hold of a calculator. That's 25. 17 squared. Can't do it in my head, or at least I don't want to risk doing it in my head. So let's see what that is.
It's 289.
Right, saves me the work. So if you take 25 away from that, you get 4, you get 264. So the square root of 264 guess I could do that. If you've got it before me, that would help.
2 square root 66.
Okay. Let me double check that I've written the right question down. And something's not right. And I didn't write the right question. That guy there is not 5, he's 15. So that's 15 squared, which is 225, which makes that 64. And the square root of 64 is 8. Okay, so a quick fix and we're good. It was 15 and then it became a 5. So we have got everything that we need. So I'm rewriting the triangle now. This angle is theta. Opposite was 15 because we know that already. Hypotenuse is 17. And the adjacent is x. So you might say, well, how's that going to help me answer the question? Which, if you might have forgotten, was that guy. But wait a minute. Didn't I call that guy theta? So really all we're being asked to do is to find the cosine of theta. And you see that triangle is designed for telling you things like that. Right, this whole horrible mess is theta. So the cosine of the horrible mess is the cosine of theta. And up here, a cosine is an adjacent over the hypotenuse. And the adjacent we just found was 8. And the hypotenuse is 17. And we're done. I mean, it's more in it than you thought. If you looked at the question, it looks like, how much can you need to do to get this answer? You can't, even if you wanted to, you can't just say, oh, I'm just going to do cosine of inverse sine of 15/17 on my calculator. If you try to do that, what happens is that you'll get an answer, but it'll be some weird decimal and it won't be the exact value. And the key is they want the exact value here, right? They don't want to know the 2 decimal places what the right answer is. If that was the case, I would just go to my calculator and do the cosine of inverse sine of that, and I'd be good. Right, so we need an exact value, so it has to be 8/17, so it's not correct. Are we good? Right, now there's not many of those guys. Let me do one of my own this time. Suppose we asked you to find the cosine of the inverse tan of 4/3. Right, so it's very similar to the one we've just did. I'm going to call this guy the inverse tan of 4/3. That makes the tangent of theta 4/3. Do you see how we used this piece of the thing to get to here? That guy is the opposite over the adjacent. So here's my angle, here's my opposite, 4, here's my adjacent, 3, and I need the next guy. 3, 4, Pythagoras, but I picked one that was easy to do this time. 3, 4, 5. So far, so good. Now, if you want to find the cosine of theta, don't you just find the cosine from this angle? And the cosine is adjacent over hypotenuse, and you're done. Now, they could have asked you for all sorts of things. Couldn't have asked you for the cotangent of theta. Well, what would that look like? It would look like this. The cotangent of the inverse tangent of 4/3, right? That's what it would look like. But essentially, it ends up being finding the cotangent from this triangle. In fact, don't all of them end up being one of the 6 trig ratios of this triangle? Now, if it was a cotangent, do you know it's the same as a tangent, but you turn me upside down? So it would be 3/4. Are we good with that question? Okay.
Yeah.
Any questions? I want to do just one last one and call it a day, and we'll finish off with, questions at the end, I guess. But one last question from this. So the one I'm going to choose is the weirdest one of them all, which is question 21. And it says to you, rewrite this expression as an algebraic expression in X. Let's see what I can do with this guy. See if I can pin it again. Okay, I got a big version, at least I have. The sine of the inverse tangent of X is what we've got here. Right, I'm going to call theta the inverse tangent of X. And instead of calling it X, I'm going to call it X over 1, which is just X, just a slightly different version of X. Now that's the same information as the tangent of theta is X over 1. Now, can you see why I turned the X into the X over 1? It wasn't me just doing it because I felt like it. Can you think of what the reason might be for why I did that?
So you could have like an opposite over adjacent side.
To have a fraction, you need 2 things, right? So X on its own would have thrown us, but X over 1 doesn't not now give us a candidate for the opposite. It's going to be the X, and the adjacent is just going to be a number 1. So I can now build my triangle. My opposite, my adjacent, and finally my hypotenuse. The opposite is X, the adjacent is 1. Now to get the hypotenuse, that's a little bit messy. So here goes. The hypotenuse squared is X squared plus 1 squared. The hypotenuse squared then is X squared plus 1. The hypotenuse is the square root of X squared plus 1. And you see that you don't have numbers to work with here. So, the hypotenuse isn't a number like 5. It's this weird square root of X squared plus 1. But that's cool. We're now being asked to find the sine of theta. Right? The sine of inverse tan, right? It's the same thing as the sine of theta because theta is inverse tan. Well, that's going to be opposite over hypotenuse. So in this case, it would be X over X squared plus 1. Now, I could have asked for the cosine, the tangent, the cotangent, you pick any of the 6 trigs, because once you've constructed this triangle, you can find the sine, cosine, anything you like, any of the 6 trig ratios of the inverse tan of X. So if you replace this sine with a cosine, then down here, this would be a cosine. And wouldn't you then just be doing adjacent over hypotenuse, which would be 1 over the square root of X squared plus 1. You see that you can get it for even that one. And to finish, a very simple question. What do you think the tangent of the inverse tangent of x would have given me?
X.
Yes. Isn't that the property of what inverse do? A function and its inverse, don't they essentially cancel each other out? So if you start with an x, you'll finish with the same number, x. As long as the thing is inside the domain of the function, which for the tangent is. Right. So we've came to kind of finish for tonight. Is there anything for the good of our business, for any questions you want to ask before we close off?
I have a question.
Sure.
About the one we just did.
Yes.
So aren't we not allowed to leave a square root on the denominator?
Technically correct, but there are exceptions to almost every rule. If the thing on the bottom was the square root of 3, we would expect you to fix it, right? I wouldn't want you to leave an answer as 5 over square root of 3. So in those situations, totally sensible. But there's a little bit of wiggle room. If the thing on the bottom is not a number like the square root of 3, like the square root of x squared plus 1, or the square root of a squared plus b squared, or something really weird and messy like that, we kind of give it a buy and say, yeah, okay, we'll let that one slide. So the answer is not a strict yes or no. The answer is yes if it's a number on the bottom. But if it's something that's got x's or ugly, square root looking thing, you can leave it. You can fix it if you wanted to, and if you did, there'd be nothing wrong in that. I'm always a little bit suspicious of the software, because you may actually do that and do it correctly, but then the software goes and says, I wanted x over the square root of x squared plus 1, and now you're scratching your head thinking, did I screw up or did I not? Now, the advantage is, if you did that in the test, you will PDF me, right? You'll send me a copy of your working. I will look at the working to that and I will say, he got it right. I'll change your grade and give you the full points. Now, you don't get that advantage in homework. It would drive me crazy if I had to do, I've got 120 of you, if I had to go through all your homework and look for that. So, you get what you get in the homework unless you decide, hey, this should be right, and you can shoot me an email and I'll look and I can fix a one-off. But I really don't have the time to scan through everyone's homework as well, especially in the fact I don't get, what's the word? I don't get a solution manual in the sense that you'd expect, that I can just compare the answers. They randomize these bloody questions. So technically, my 120 students could be doing 120 different versions of each of the questions they're doing. I want to keep what little hair I've got. So for tests, it's big, because tests give you a lot of points, and tests I'm willing to put the effort in. And when you send your work in, I will go through each one of your answers and check it against the grid. And if something is right, in my opinion, and they couldn't handle it, I'll fix it for you. Are we good? Right. Now, this has happened in a different situation. Someone was doing something else, and then after they did it, I'll give you an answer. They wrote down 7.5, right? 7.5, which is an improper fraction, which we don't use in math, right? 7.5 should be called 15 halves. And after they got like their last attempt at their homework, which meant they couldn't do any more, they shot me an email and said, I now know what I have done wrong. I should have said this. And I went in and checked it. And in that one case, I did change it for them, with a caveat that I'm only changing it once. From now on, if they say 17.5 or 7.5, they're wrong, right? They have to do it as a improper fraction and so on. Second issue is not your fault, but I can understand why you're doing it in the homework. If they give you the answer to 3 decimal places, then that's what they're looking for. So don't try 4 and don't try 2. It probably will kill you and, dock a point So be careful. And the other one is, don't give me a decimal version of the square root answers. Do you know if the question wants the exact value of something? The answer is 5/17 or root 2 over 2. Right? Don't tell me it's nothing 0.123. And the reason I'm saying that is because I believe in some of the questions, if you put in the decimal version of the right answer, it will probably accept it. It shouldn't, because it said, I want the exact answer. And so it's up to you to just get into that good practice, because you know, you're going to move on from here, and I don't want you picking up bad habits that you're just going to get dinged for in future classes, where people will say, who on earth said it was okay to turn everything into a decimal when it was an exact value that was being asked for? I'll probably give you more information you wanted there, but that's fine. Any other questions? Okay. Now, I'm in and out all day, every day this week. So if you have any issues in the next two sections, or you come across a question from this section, shoot me an email. I'll try my best to answer it by email. If that doesn't work, we'll do a Zoom one-to-one meeting. The two sections that are going to come, if you read over the notes, they're pretty much, what's what I'm looking for? It's very systematic. You know, once you've done 2 or 3 of them, you know how to do all of them, right? It's a kind of plug and chug kind of process. So make sure that you're comfortable and you know what to do, and you do like the step 1, step 2, step 3 thing. That's kind of how you do these questions. And whenever it's a story, draw a picture, right? And you'll be good. Now, the difference with the next 2 sections is the triangles are not right angled anymore. So you're going to have to use different rules. You're going to use the sine rule and then later on the cosine rule. So, you know, the world has now changed. And so don't start using SOHCAHTOA for any triangle in the world, because it won't work. It only works for right angles. And that is it. Are we good to go?
Okay, does this count as like a point in the participation grade?
It does technically. I'm having a real trouble trying to keep track of that. So I'm going to ask you to keep track of it. And if you send me, that's how we're going to do this. At the end of the 2 weeks, right, on the day of the final, when you're doing your PDF, if you could just put a little note and say, I attended 4 meetings in the last 2 weeks. I'll trust you on that. If I see someone's name that I've never seen before, tell me it's 4, then I'll be very suspicious. But it tends to be the same people who comes to everything, so you'll be good. In fact, it won't take you that long to get your 10 visits. So once you've got that 10, please keep coming, because hopefully I'm doing some good. But after that, it don't matter, right? Because you can only get full points on your participation. That's it, over with. Okay, that's it, I think. Bye-bye, everybody. Have a nice day. Well, what's left of it.
Have a good day.
I'll see you Friday, okay? Oh, and on Friday, we're going to look at sines and cosine rules. So that's what our lesson's going to be about. Bye-bye.